Hi, everyone. I'd like to start by apologizing for my English. It's a bit rusty. I hope that you understand most of what I have to say, and maybe have a few laughs. Today, we're talking about rapid prototyping as a way of life. Clicker. Shall I wait for another minute, or shall I start? Rona? Yeah? OK. Cool. So I don't know if anyone can get the joke of the picture at the bottom. But while you ponder that, I'll talk about myself for a bit. My name is Zohar. I've been a web developer or a developer since late 2004. Currently working as a CTO at QuickLizard, which does dynamic pricing for e-commerce. And I chose to talk about rapid prototyping not as a concept on its own, but rather as a way of life for developers. The gist of it is how can prototyping as a culture can save us time, money, and sanity. OK, so basics of rapid prototyping. From what I read on the internet, it actually originates in industrial design. But the gist of it is that we want to test a theory fast. So let's say that I'm trying to make a car or a chair. I'm not going to start producing a car by building a car. I'm going to build a prototype, see what the problems are, and improve on that until I get to a car or a chair or whatever it is that I'm trying to build. And the same goes for development as well. If I have, I don't know, a new app to build, I'm not going to start with building an app. I'm going to start with something a bit simpler, test my theory, see that, I don't know, my UX is OK, that my APIs are working, and then advance until I have a working product. What we're trying to avoid here are two things. We're trying to avoid red tape. So especially if you work in a bureaucratic company, product design is a very lengthy process. And it's easy to make a lot of mistakes along the way. And if you waste time on red tape and bureaucracy and meetings and designs and so on, you're not actually testing your theory. You're not actually testing and finding out whether the app works. And the other thing that is important to remember when we're doing prototyping is that we're not committing to a final result. So it's very similar to Agile. There is a goal. We're not committing to that goal. We're committing to a very short-end or short-term result. And that's prototyping in a gist. OK. So I was looking at the fonts. Did that on a Mac, and obviously on Windows it looks a bit better. Prototyping is not just about building cars or building UX prototypes. I think that prototyping in UX and UI is very, very common, but we can use that concept any way we want. So basically, if it's big enough, we can prototype it. If it's small enough, we don't need to bother. But that means that if I want to try and move from Angular to Vue.js, chat I had an hour ago outside, I'm not going to do an entire rewrite in Vue.js without testing it first. I can do a prototype. If I'm trying to test out a new CSS framework, I can do a prototype. If I'm migrating code to a new database, whatever it is, I can prototype it. APIs, I can prototype. New models, I can prototype. And that sort of iterative process of thinking about a very short-term test that I'm trying to do, achieving that, seeing how it works with the rest of my environment, so with the rest of the application, with the rest of the code base, is the way forward. I see that don't panic is a common common phrase this afternoon, and it's a good one. So when we're talking about prototyping, not just as a one-off, what are we trying to do? What are we trying to achieve? First of all, we need to identify our goals. What am I testing? What am I trying to prove? Am I trying to prove that my user experience is good? Mobile applications are a fantastic example because UX in mobile applications is very different than UX on the web. Okay, it's gesture-based, smaller screens. I need to test that everything is in place, that I got my code right. So did I choose the right tools? And I can do that by prototyping. I need to define the goals. So my first goal is, let's see if doing hybrid versus native works for the team. Okay, that can be a prototype. I'm going to stub or mock anything that's not related to the test. So if I'm doing a new single-page application, and I'm starting from the front end, I'm going to mock the API and the database. No need for API and database. I'm actually trying to do only the front end. I'll worry about that later. There are tons of mocking libraries and ways to fake data, okay? What we're trying to do here is we're trying to avoid time wasters. And this is something that I'll say over and over again in the presentation. But if you treat your prototype as a project, you're missing the point. The point is to do something very, very quickly, not cheap and dirty, but quickly, to prove a point, see that it works, and then move on. Okay, so we're trying to avoid time wasters. I'll give you a little story. I sat with a guy 2 weeks ago, I think, and he said he's trying to improve his resume, and he's working on a React project. And I asked him, OK, what did you do? He did some sort of a music player library thing, I think, and he described all the components that he wrote. And I asked him, OK, why did you do it like that? And, why not actually take just the HTML, whatever CSS library you're using, and just build a static page? Do that. Once you're happy with the way it looks, identify the components, then start extracting components into React. So React was a given. He had no question about using another library. Start extracting that. Once that works, put the state management on top of that, connect it to the web, and so on and so forth. But every step of the way, you can actually test your theory. So does my UI look OK? Is this what I'm aiming for? When you're componentizing things with React or with Vue or Angular, that's when you're basically prototyping your entire code structure, OK? And you can decide where to put things and how things should be divided and so on. And only later, when you connect things to the backend, you're actually prototyping the data layer, OK? But if you think to an instance when you did something similar, when you're writing the components, you're already starting to think about what the data is going to look like, OK? So you're actually prototyping here rather than writing code. And then when you get to that stage, everything is ready. Okay? You don't have many questions open about what the data layer is going to be because everything is already set. Okay? Back to the point. Avoid time wasters, please. Don't waste time on things that are not important. If you're focusing now on UI, don't do backend. If you're focusing on writing a daemon, don't deal with the database. Write the daemon code. Make it work. Then connect the wires. Next point is pretty related. We're looking for a quick turnover with minimal friction. Minimal friction in that respect is all the overhead process, meetings with design people, meeting with product managers. Because we're doing something that's very small, it's very easy to communicate. So I can just grab someone, and send them an email, grab them in a hall and say, look, this is what I'm working on. I'm going to do it. I'm going to finish by tomorrow. I'm going to show you something, then we can move on. OK? No time wasters. Next slide. OK, another picture of a robot. So I tried to coin a phrase called continuous prototyping. I hope that I'm not infringing on anyone's copyright. But when I spoke about this presentation to someone who knows about prototyping but doesn't work in a continuous integration environment very often, her feedback was that, OK, so fine, yeah, I get it. I prototype, and then I move on and build the actual thing. And I'm like, no. So your goal is, when you're doing continuous prototyping, when you're adopting prototyping as a way of life, it's something that you do continuously, OK? It's not something that you try to prove to your manager, yes, we should go with that CSS framework. Yes, that design looks better or works better. It's something that you sort of integrate a bit more into the development process. I'll talk about it in a minute. And instead of throwing away your prototype, you say to yourself, OK, fine, I'm going to test it. Worst comes to worst, I'm going to throw away 2 days of coding. But if it works, I'm going to keep the code. OK, and I'm going to go to the next phase. I'm going to build the next thing. And then if it works, I'm going to go to the next phase. So what you're actually doing is you're dividing your work or your big task or a big goal into a series of tests or a series of proof of concepts that you're keeping instead of throwing away. One thing that once I realized that that's the way that I actually work at least 50% of the time, it's actually really, really cool because you can do something very quickly and get a quick turnover and be happy with the result. But if you decide from the start that you're going to keep the code, you actually invest, I don't know, 2-3 hours more and make the code a bit more beautiful and make it a bit more organized. And then when you go back to it, because the test worked and your boss is like, yeah, sure, that works, let's do that. You don't have to rewrite it. You actually you only have to improve it. So next point is that in continuous prototyping, as I said, we plan for the final product, but we're only prototyping the basics. It's very similar to continuous deployment, continuous delivery, whatever you want to call it. We do very small iterations. The only difference here is that instead of delivering a feature, we're testing a theory. And if our test is correct or if we got the result that we wanted, we go ahead with the next phase. And if not, we go back to the drawing board, change whatever we need to change, and move on. OK. So I think that's, oh, wow. They told me that I have half an hour, and I did this in a bit less. So you'll probably have, no, we'll be all right. If you can take anything from today's presentation, I want you to take this. Because as I said at the beginning, rapid prototyping is something that I think at least some people are aware of, and some of you did in the past. So it's not a foreign concept. But it is a foreign concept when you're talking about the process in a company. Okay? So I work for a company where part of the time I do CTO stuff that has to do with selecting technologies and writing architecture and DevOps and all that. And part of the time I actually do prototyping for the company, and I implement the next product. Okay, only the basic. And then I deliver the code to our team, and then our team takes it from a prototype to a product. But the mindset of the company is we don't have big stuff, we don't have a lot of money, and we need to do things very, very quickly. Instead of doing it dirty, we're going to do it prototype-like. And that means, first of all, it's an official process. Okay, today I deployed a prototype that I wrote last week. I'll be happy to tell you about it in a minute. And it's part in a series of tests that we're implementing on the way to a product or a feature in our product. The thing that helped me the most is that because I'm aiming for a goal, so the feature request was build me a mobile application, or I want a new API for the client. I'm looking for the fastest turnover I can get to get something out there as quickly as possible. And therefore, I will always do the lowest hanging fruits first. If something is easy, I'll do it first. If it's easiest to do the UI because I already have it in mind, I'll do that first. If it's easiest to do the backend because part of it is already written, I'll do that first. The benefit of this approach is that you get the working result very quickly, and you can prove or disprove part of the whole theory of whether this feature works or whether this product is needed or whether that we need to prepare a demo for a client. It's out there, and it's already getting traction, and you can already measure things, and you can already see what works, and you can already incorporate conclusions that you have from the prototype that you released and take it back and then improve on it in the next stage. So be lazy, do things quickly, and look for things for the fastest turnover that you can. The next thing is that we always have allocated time slots. So because it's very easy to break the big feature into small prototypes. I'm talking about feature, but it's not a feature. I'm talking about like something that we want to release. It's very easy to break it down. I'm going to say, yeah, sure, on Thursday, because it's a no deployment day, I'm going to work on that. And then things become very predictable. So it's not something that's obtrusive or in parallel to the development cycle. It's part of the release. We're going to do the prototype, I don't know, over 2, 3, 4, 5 releases, depending on the prototype. We're going to dedicate a bit of time. We're going to do things quickly. And then you'll notice that when you have, I don't know, half a day spare because you finished something early or whatever, you're going to go back to the prototype. Hey, yeah, I'll just do a few more things here, improve on that, deploy it next time I can, and then you're bringing your prototype into the fold, and it becomes a continuous delivery or continuous deployment or whatever it is that you do in your company. Last thing here is that we always aim for early deployment and integration. If it works, even if it works just enough, just well enough, and I'm talking about backend and frontend, okay? If it works, let's release that. Let's test that in production. Let's test it with live data, with live users, with demo users, with whatever it is that is going to help us realize what the problems are, okay? So if I can recap from the start about prototyping as means to prove a theory very quickly, and all the way to incorporating it into your company process or your way of life, state of mind, quick turnover, it's not a one-off exercise. Avoid time wasters and aim to deploy quickly. I think that if the company is big enough and has enough set processes of how to deploy codes, that's going to be the biggest problem, because you don't want to bring code that is sort of untested to your live environment. But if you can convince, or if I can convince you that you can do it risk-free most times, then I think that the benefits here are huge. Because if I am able to add a new section to our application that is only visible to a certain login, and I did that in 3 days, which in development time is nothing. It's not perfect, but it's working. And I can send that to head of QA, head of design, head of product, whoever needs to look at it. 3 days, and they'll have feedback. They don't have to wait for another release to get feedback on whatever it is that we're developing for them. And I think that's the biggest benefit of going from a one-off to a process. Okay, real-world example. I'm doing really well for time. So I'll give one, maybe more. We had a problem at QuickLizard 2 years ago. Our backend is mainly written in Ruby. And the best feature of our application is that we're able to create Excel reports for our users. Our users are from enterprise, e-commerce companies, and they love Excel. And the engine that generated the reports was too slow. There was one report in particular, it didn't work because it's Ruby, and Ruby wasn't designed for that. So the prototype was find an alternative. What is the best alternative in our existing code base to write or to create a worker that can generate reports in Excel? And the process was like that. Okay, first question, what can integrate with our runtime? So there's JRuby, which I tested. I wrote a very stupid worker that can just get work, do something, and give it back. Measured performance, measured resources, threw JRuby out of the window after 2 hours. Okay, that's a very successful prototype, by the way, because I didn't waste any time. And then I looked forward, onwards, and I ended up choosing Go. And the reason I chose Go was because it's compiled, and they have a library that talks on the same wire protocol as our workers. So integration was very easy. I just had to learn Go. And then the process was like that. OK, I chose Go. I consulted with my boss. I said, yeah, that's fine. First iteration, write code in Go. Took me a day. I wrote something in Go that works. Second iteration, write code in Go that actually speaks the wire protocol. Did that, works. Third day, improve on that code again. Write something that writes in Excel. OK? So write something that creates an Excel report. And by the third day, I was able to run a very ugly worker written in Go, my first ever code, that got messages over the wire, created an Excel, speaking with our API. Very stupidly, the code was improved afterwards. But I was to say that in praise of Go, that I was able to go from 0 to working code in 4 days. And it was literally that. First day, learn the language. Second day, write some code that talks to the workers. Third day, write Excel. Fourth day, improve and try to deploy it. And we were able to replace the worker not after 4 days, because obviously we had to test it a bit more. But it was very, very quickly after that. Had I found out that Go is not the right language, I probably would have found out about it after 2 days. OK? So making a mistake at that point wasn't a big deal. OK? It was just, yeah, fine, replace that, look for something else. Second example that I can give you, which is recent from last week and this week, is that I had to write a prototype for an API. And it's an API that we hope to give to our clients so they can get their price recommendations in real time. And obviously, we don't have any algorithms yet because the API is not there. And getting the data scientist to write algorithm is going to be a headache. So I just wrote the API. It basically gets a request, does nothing in the backend, it randomizes the number, returns the response back to the client, and that's it. Yesterday, one of our developers did the first integration with that API. Today, I deployed the second integration with that API, and everything is non-obtrusive. So basically, once the API was up in the air, it didn't talk to any service in the system, so that's not a problem. Yesterday, she added something that mocks a bit of data. Again, doesn't talk to anything in the system, no problem. Today, we deployed staging code that actually does talk to a little bit of a few components in the system. And all that it's supposed to do is generate data. So now we're collecting data for a week. I'll come back from holiday next week, and I'll be able to prototype some UI. OK? But every iteration is between a day to a day and a half long. And at any stage, we can decide, OK, that doesn't work. Let's throw it away. We just threw away a day's worth of coding. It's not a big deal. Until everything is sort of satisfactory, and we can say, yeah, fine. That's stable enough and looks good enough, so we can actually make it into a component or a feature in the system, and then move onwards. And thank you very much for your time.